All right, let's go. So for everybody's sake, I'm going to fully run through how you find the gradient of a curve using limits. We call this the intuitive approach. It's on the syllabus. So let's run through it one more time in detail. Do some questions on it, right? Finding the gradient of a curve at a point using limits. And this is the intuitive approach. All right, so you can copy that down, right? And basically how it works is the main thing we have to remember is, tell me, Amy, what's the simplest formula for gradient?
Y2 minus Y1
Right.
over X2 minus X1.
So we gotta ask ourselves, what is the simplest way to find gradient? Now that formula you gave me, right? That formula is for a straight line or a curve.
A straight line.
Ah, so gradient M is equal to y2 minus y1 over x2 minus x1. Okay, and now we need to put that this is specifically for a straight line. Why is it for a straight line? What do we know about straight lines? Tell me something you know about straight lines.
The gradient is the same throughout.
Yes. So when you use this formula, you're finding gradient, and gradient refers to the steepness. If you have a line, then the degree of steepness is the same, right? And what I mean is, imagine you have a straight line like this, and the angle, no matter where you read the angle, and the angle would always be the same. The degree of steepness, angle of steepness is the same, right?
Mhm.
But you can't see the same thing if we're dealing with a curve. Let me just say we have something like that, right? Would the angle here be the same thing as the angle over here?
No.
No. So the main thing we need to know about straight lines is gradient is the same everywhere. And that's why it works. When you look at straight lines, gradient, gradient is the same. Okay. So Amy, we need to now apply this to a curve. Now, what is the weird thing about a curve?
The gradient different at every point.
Right. Now, how does this help us find the gradient of a curve? How does that help us find the gradient of our curve? Now, if we use this formula, if we use the formula above, we will get an estimate. Right, and let's look at that. By the way, again, I'm moving too fast again. I'm trying to copy this up.
No, I copied it down. No.
Okay, cool. You have everything there?
No, I'm not writing. How does this help to find the gradient of a curve?
Okay.
I finished.
All right. Second master. Right. So let's let's look at it. Let's look at how this formula will help us when dealing with a curve. So let's say we have a curve. Okay. And let's just say we take a point. Mm, okay, Amy, let me just say we take let me go back. Okay. Yeah, Amy, if I were to take those 2 points and I were to find the gradient of those 2 points, does it look like it? Does it look like it's accurate? Tell me. Yeah or no? Does that look accurate? Amy?
Hello, you hearing me?
Yeah, here,
Okay, I said no.
No, because look at the steepness of the line, but look at the steepness of the curve. So we need to make a little note of that, right? The gradient the gradient of the curve changes at every point. Matter of fact, this here, right? So the line, so the gradient of a line so the gradient of a line is just an approximation. Right. So this is what we're seeing. This is what we're seeing, right? Um, we're seeing that have a point here, have a point here, right? I'm getting into these specifics now. Okay. So remind me, right, Amy? I have these 2 points over here. One represents the distance between them again.
H.
H is the distance between those 2 points. If I have the first point, this is the first point over here, then the first point will have coordinates what? What would the coordinates of the first point be?
Of X.
X, comma,
X comma f of x.
right. And this one over here would be, so if this is X, then to go to this point, you would have had to add H to it.
Is x plus h.
And then you go plug that into the function, so that'll be X plus H, comma, F.
F of x plus h.
Correct. Now we clearly see what happened in here. If you find the gradient using these 2 points, it will not be an accurate gradient of the curve. So what we could do is we could let me just put L not accurate by it. Not very accurate. Not very. Okay. So what if we do this instead? I'll leave in the x f of x the same way, the same position it's in, but I'm decreasing the distance between 2 points. Right? Okay. So Amy, we want me to move the point. Should I move the point further away? You think that'll help make the gradient more accurate? If I move the point further away?
No.
No, if I do that, it will it would be less accurate, right? This looks a lot worse than this. So I should move the point closer to the other point. What if I had moved the points over there? Let's see what happens. So I'm going to draw a line. Does it start to match or better represent the gradient of the curve?
Yeah.
Yeah, again, a lot closer, right? So hypothetically speaking, if I were to overlap those 2 points, if I were to overlap those 2 points, what would happen?
The gradient will be accurate.
Yeah, the gradient will be accurate, finally. And I want you to notice something, right? As we keep doing this, and you could see that if this point on top of this point and the x value and the f of x value would be the same,
Yeah.
the x and the y value will be the same because it's on top of each other. Okay, cool.
Mm-hmm.
Um, all right. Aliyah, you joined late. What was the reason for that? Is it your laptop again?
No, I was baited, because I eat kind of late and then I was helping mommy with something.
Oh,
Yeah, sorry about that.
but you know class is 10.
Yeah,
Okay, well, just make preparations to join a little bit earlier
yeah.
because if I wasn't doing this topic what we did last class, it'd be a lot, you'd be very lost if I did do something that you wasn't familiar with.
Hmm.
Like let me see if you understand what we're doing here. Which one more accurate? This one or this one? This one or this one? Do you know what I mean when I ask you which one is more accurate? Tell me, be honest. When I
Um,
say which one is more accurate, what I mean by that?
which one, like the point, the 2 points on the curve? Like,
Now, that's not what I'm talking about. I'm talking about the gradient. You understand that y2 minus y1 over x2 minus x1 is the formula you use to find gradient of a line.
yeah,
Okay, would you use that on a curve?
no,
No, because the gradient of a curve changes at all points. But let me just say you do use it on a curve. Would you want to take 2 points that far apart?
no,
Because look, this is a line you're drawing. Wait, that's the line you're drawing, and this is the actual gradient. Okay, so that's not very accurate. What about this? Let me see if this
yeah,
can accurate.
yeah,
It's starting to get closer and closer. So
mm-hmm,
what we're saying is, if you put this point on top of this point, it the gradient will be perfect. It will be
yeah,
accurate as possible. And in maths, we refer to that as taking the limits. We looked at limits last class. And I see another perpetrator. Kira, you say that joined class today. Joined real late. At least you joined. How come you joined so late?
I was sleeping.
Yeah, well, you know class is 10 o'clock. You should wake up a little in advance, right? Should wake up a little earlier. Did you set an alarm?
Yeah, that's a joke.
Okay, well, you need to make preparations to wake up before 10 o'clock because it's 10:34, right? Um, so yeah, Aliyah, this over here is much more accurate. So this is much more accurate.
yeah.
So what we trying to do then? We trying to we trying to take this point and overlap it with this point. So if we do that, what is happening to the distance between the 2 points? Tell me, Aliyah, what is happening to the distance between those two points?
It it becoming less.
Right, so it's approaching what? From limits. Try to figure it out. To get an accurate gradient,
Um, waiter, it approaching.
think about it. So we want what? We want this and this to be overlapping. You know what overlapping means?
On top each other.
Right, if they're on
So
top of each other, where's the difference between 2 points? Like where's the distance?
0.
So if look how what happened, right?
So it can reach
It go approach what? H approaches
X.
X,
Oh, you mean 0?
0.
Yeah.
H is not X. H is the
Yeah, yeah,
distance between the 2 points. For me to get an accurate gradient, the distance between the 2 points has to be
yeah. 0.
yes.
Yeah.
And you would have see what happened. Over here, the distance was wider. Over here, closing the distance. And
Mm-hmm.
last scenario, if they're on top of each other, then the gradient is, well, not the gradient, the distance is 0. So to get an accurate gradient, we look at what happens as h approaches 0, and there's limits. So, Aliyah, I know you wouldn't be able to copy all of this song now. That's not my fault. You should have joined earlier. You could always look back at the notes. Kiara, same thing. Amy, where did you reach in taking down the notes?
The very last statement that you just read. The
Oh,
last
okay.
part.
So I'll send the notes right after class, and whoever came late, y'all could make the changes and add in the information. So now we need to look at this as a equation. Okay. So Aliyah, what is the general formula for gradient? Gradient. You remember the
Y2
formula for
minus,
gradient?
yeah, y2 minus y1 over x2 minus x1.
Okay. Nice. And we always in these kind of questions we always considering x to be the first point. So this is the first point. So and this will be the second point. So can you tell me what the gradient formula would look like?
Y2 could be f into x plus h
Yeah. So let me
minus
write that down. This is x1, x1, y1, x2, y2. Yeah. So y2, that's f of x plus h.
minus f of x over x plus h minus x.
Right? X plus h minus x. And what does this simplify to? Oh, by the way, this is the approximate gradient. I could just say estimated gradient. Yeah. And Aliyah, what does this simplify to? What does this simplify to? Can't simplify anything on top.
No, so just be that over h.
Yeah, I remember last class we looked at that.
Yeah.
And you said, well, and I could just write h. And I was like, yeah, could just write
Yeah.
h. But this over here, this is not the actual gradient. This is the estimated gradient. This is the rough, it's the rough, it's a rough idea, right? This is just taking 2 points on a curve and finding gradient. But now, to get the actual gradient, right? The proper gradient, we need to do what? To find the actual gradient. What are we gonna do? So Aliyah,
You're gonna
we have a function here, and we get the actual gradient when
h is equal to 0.
no, don't say equals to
Well,
approaches.
when
Say
h
approaches.
approaches 0.
Right. Yeah, because I'll tell you why. If h, let me just take a point here. Let me just say that this point over here is 5, 0. If that is the case, NT will be saying that 5, 0 is x1, y1, and 5, 0 is x2, y2. Because here, it's Aliyah, right? And we saying the 2 points had to overlap. And we say
Yeah.
that the 2 points have to go on top of each other.
Yeah.
So if they're on top of each other and in the same place,
Mm-hmm.
so then this could be x1 and this could be This could be the first point and this could be the second point.
Yeah.
You can find gradient of that. Let me try. Where's y2?
0
You're gonna put 0 minus 0 all over.
over 5 minus 5. So
You're
0.
gonna end up with 0 over 0. That's not that. Put 0 over 0 in your calculator. Put 0 over 0 into your calculator.
It's saying math error.
Yeah, because if I recall, we cannot divide by 0. I know all you're thinking, right? Like 1, 0 would make a 0. But still, you can't divide by 0. That is why we need to find the limit. So, Aliyah, yeah, if you do this directly, you're not going to get an answer. You can't divide by 0. You understand? We can't divide by 0. We cannot.
Yeah.
What we can do is take the limit. And the limit is what happens as we get closer to 0. Amy, explain that one more time. What is the limit? Like in this question, we can't just do this. You'll get an error. So we need to find the limit. What is the limit? What is that about? Tell me, Amy, what is the limit about?
That's when h approaches 0. So,
Yeah, that's correct. So again, smaller, 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 but not quite reaching 0. So like again, smaller and smaller and smaller. It reaching 0, yeah. Again, closer to 0. But do you think it'll ever actually be 0? Tell me, Amy, do you think it'll actually ever be 0?
I don't know. Maybe.
No, it would never actually be 0. Consider 1 over a billion. If you think about 1 over a billion, right? That's a real small number, and
Mm-hmm.
for all practical purposes, and that's basically 0.
Yeah.
But mathematically, and it still have a 1 in there somewhere.
Yeah.
Yeah, that's what I'm saying. It will never actually be 0, but for practical reasons, it is 0. Because it's so small, you could just call it 0, right? Just call it
Yeah.
0. Right. So the actual gradient, Aliyah, if you want to find the actual gradient, we need to find so that's what L,
The limit
as what?
as h approaches 0.
Yes, ma'am. For this. And that's the actual gradient formula. You just need to remember this. But if all you forget in the exam, well, now you know how to figure it out. You're not totally lost. But it's very weird. Okay. What? Anyways. Copy this down. And the main thing I want you all to you can copy down this, right? This is the way getting into the answer. But this is the main thing you need to remember. The formula. So I'll give you all some questions. So yeah, in this class we'll start product, quotient, and chain rule. And you'll like those things. And you're
I
looking.
don't.
Kira, have you ever done quotient, product, and chain rules yet? Have you done those things?
We only started in school recently.
Okay, and where was it? What was the last thing you all did? What was the last thing?
The quotient.
Okay. Right, so as soon as you'll have that gradient formula copied down, we'll proceed. All right. Aliyah, you have that formula copied down?
Yeah, I'm writing it down on the last line.
Okay. Right. Okay, Amy, ready to go?
Yeah.
All right. Kira, are you copying this down?
I finished copy down.
Okay, cool, cool. Amalia, I guess, and you finish, huh?
Yeah.
All right, nice. So we look at an example. By the way, do you all recall doing these questions from last class? Find any limits of these things.
Yeah. Yeah.
Aliyah, you say yeah. Kira, you wasn't there. Okay, so Kira, I'll run through it for your sake.
Okay.
You ever do limits in school?
Um,
No? Okay. Well, let me explain something real quick. Let me look at what happens. So, Kira, if h, imagine that h getting small, small, small. H is basically zero, right? Where's zero squared?
0,
What is 3 by 0?
0,
Right. Um, if we have 3g cubed over g, is there anything we could do to simplify this before we find the limit? Could I simplify this? I have 3g cubed over g.
no,
Yeah. If I have g cubed and I have a g in the bottom, I could cancel off one of the g's on top. So I have 3g squared.
oh,
You didn't see that?
is it? I mean, I saw it, but like,
It was like,
yeah,
you remember what g cubed means? What does G cube mean? If I say G cube, what's that?
G by G by G.
Okay, so what happen next?
One of the G's cancelling off one of the G's.
So you'll be left with
G squared.
right. If anytime you get confused, just go back to the basics and you can figure it out. And if G is basically zero, G is G Z, Z, zero squared is zero, 3 by 0 is zero. Answer is zero. This thing looking easy, right?
Yeah, I guess.
Okay. Now we have minus 3 over A. What happens if A gets bigger and bigger and bigger? What happens to this fraction? So this number in the bottom getting huge.
The fraction getting um would it be like smaller? The fraction getting smaller?
Yeah, because if the number in the bottom getting huge, then this fraction getting smaller. And eventually the fraction go approach what value? If it's getting smaller and smaller and smaller, it'll become very close to what value? If it's getting smaller and smaller and smaller and smaller.
Infinity.
Okay, so you think
Like
so you're telling me
infinite
that
amount.
infinity is getting smaller. Think about it. Would you say that okay, if you say you have an infinite amount of money, does that mean you have a little bit of money or like plenty of money?
A lot.
So if every fraction is getting smaller, do you think you have an infinite amount?
No.
No. If I say the money in my wallet getting smaller and smaller and smaller, eventually how much money I have in my wallet?
Zero.
So this fraction would eventually become
Zero.
yeah, because again smaller and smaller and smaller. It wouldn't be infinity, right? What about this question? You need to simplify before you do anything. You need to simplify before you do anything. So how would I simplify this?
Um would it be and this is like we could use indices here, but like if it's like divided, that means like we're taking away.
Yeah,
So it'll just basically be um a to the power 2 minus a to the power 5. So it'll be 2 minus 5 and it'll be a minus 2.
yeah, that's correct. Nice, nice. And what is a to the power minus 3? That's the same thing as what? A to the power minus 3. We could probably write as a fraction. A to the power minus 3. Anytime you have negative powers. Can somebody tell me what negative powers are? They are what? A negative powers. That's with F. Here.
Fractions.
Yeah, fractions. So Kira, I could write this as 9 all over a cube. Could write as 9 over a cube. Kira, another way you could think about it, right? You could I go back to the origin, like the starting days. Right, so Kira, I have 2 A's on top and I have 5 A's in the bottom. What happened?
Two in the is will cancel.
Yep, that's what would happen. So what would we end up with? What would we remain with?
minus 3 because it's on the bottom, right?
But we're going to leave it in the bottom. We're going to leave it in the bottom for this question. So that'll be 9 all over.
A to the power minus 3.
No, a to the power 3.
Oh.
The only time it's minus is if you bring it up to the top. But we didn't bring it up to the top.
Okay.
You understand why you're confused?
No, I understand.
Okay, and I want to ask you this. If the number in the bottom, so they say A approaches 0. If something approaches 0, is it getting bigger or is it getting smaller?
Smaller.
So if the number in the bottom getting smaller and smaller and smaller and smaller, what would happen to the fraction?
It will eventually be 0.
No.
It will eventually
Think about
be
that, eh? Let me think about it. I see the number in the bottom again small.
Mm-hmm.
So like think of it like this. Let me say we start off with 9 over 10, and then become 9 over 2, then it become 9 over 1, then it become 9 over a half. What happens to the number?
Oh, again bigger.
Right. What about 9 over 0.00001? Then that's a small number or a big number?
Um,
How I
big.
think about it is that, yeah, how I think about it. If you have a small number here, and you go take more of those small numbers to make 9,
Yeah.
right? So eventually, imagine if you were saving money and every day you gain $1. How much days it would take you to save $9?
9 days.
Okay, let me just say it was getting 50 cents. How much days it would take you?
18.
All right. So the less amount of money you gain, the more days it would take you.
Yeah.
So if you was getting practically no money, and they would take you an infinite amount of days to save $9.
Yeah.
So where you think this fraction, so where you think 9 over a cube will approach? If a is approaching 0, if this getting smaller and smaller and smaller, your fraction will be equal to what?
It will be equal to a whole number by then. Like 9.
9.
Will it
Nah,
not be 9 if like the bottom going nearing 0 and the top?
that means the bottom getting smaller and smaller and smaller and smaller. So the amount, whatever you have here, getting smaller. Hmm. So listen to the example again. If you was getting $1 a day, how much days it would take you to save $9?
9 days.
Okay, what if the amount of money you're getting gets smaller? Let me just say you're getting 50 cents now. How much days it would take you to save $9?
18 days.
So if you were saving $0 a day, right? How much days it would take you to make $9?
Um, infinite amount of days. I mean, if you're getting no money, how do you say?
An infinite amount of days.
Yeah.
Yeah, so that's the answer, infinity. Because if this number getting real small, then it will take plenty of this to make 9. But if it's 0 over here, then it will take an infinite amount of zeros to make 9. You understand that? It's still someone a little confused.
No, I understand.
So let me. So I'm just gonna check up everybody, right? Okay, Amy, quick. Let me just say I have a function 2 over h. If h if h approaches infinity, does it get bigger or smaller? Does the fraction get bigger or smaller?
Laura.
Smaller, and it would approach what?
0.
0. Aliyah, let me just say I have a function h squared over h cubed. Let me just say h approaches infinity. What happened there?
It'll be equal to 0.
Right, before it's equal to 0, you're correct. But before we say that, we have to simplify it. What would it simplify to?
H.
H. Final thing? Final answer?
0.
You know, asking it if H is the final answer. Like, that's they showing
Oh,
like that?
no.
Wait, what would it look like? Is it H or 1 over H? Because watch, you would have two H's on top, and you would have
Yeah,
three H's in the
one
bottom.
over H.
1 over H, yeah.
Mhm.
Yeah, and if the number in the bottom getting real big, what happens to the fraction?
It
Number in the
will.
bottom getting real big. So like
Mhm.
the fraction denominator getting bigger. What happens to the fraction?
It'll get smaller.
And eventually it'll get so small it'll be equal to.
0.
All right, Kira, your turn. All right, Kira. What would this fraction simplify to?
H to the power 3.
Right. And if h approaches 0, what is 0 to the power 3?
0.
Yeah, so this one is just 0. What about if we had h to the power 2 all over h to the power 7 as h approaches 0? First of all, what would that simplify to?
H to the power minus 5.
Right, but let me look at it as a fraction. It'll be easier to see it as a fraction. What would this look like as a fraction? I want you to tell me how it would look like as a fraction. Sarah, do you know what that would be as a
I
fraction?
I confused by what I mean. I look at it as a fraction.
Okay, you told me the answer as a in index notation. You told me h to the power minus 5, right?
Yeah.
That's correct, but that's not a fraction. I want you to tell me it's in fractional form. So like, I mean, like 1 over h or something like that. So I mean, so watch. I feel like it's still confused.
Um.
Check it out. If it's h squared, right? What would I mean on top? H squared.
H by H.
And in the bottom, what would it have in the bottom?
H by H 7 times.
What would happen?
Too many H's so they cancel out.
Right? Yeah. So you're gonna put what?
0 over H to the power 5.
No, that'll be 1.
Oh, okay.
1 over h to the power 5.
Okay.
Mm-hmm. And if the denominator, if this thing getting smaller and smaller and smaller, it approaches 0. What happens to the fraction?
it will reach like an infinite amount.
Yep. So that would the answer for that would be infinity. Nice. So let me look at the actual question now. And this was the question we looked at last class, but I'm gonna do the full working now. So before we do actual question, let me just look at this. Let me just look at this example. Right, let me look at this example here. Um, right, example. Okay, with these kind of questions, Amy, do you remember the main steps of these kind of questions? Anytime you have a question like this, what are the main steps?
Expand and simplify.
All right, so we want to expand for sure. Then we want to simplify. And it's only then after we simplify, we're gonna wait. After you simplify, you might have to factorize. Expand, simplify, factorize, and then you might have to take limits. Then take limits. Right. Cool. Let's go. So the first thing we're gonna do is, Kira, what's the first thing I had to do with this expression before I could actually find limits?
Simplify.
Before simplify. Before simplification. Before we could simplify, what we had to do? Look at this, look at the expression. You have x plus h squared minus 3 minus x squared minus 3. We had to do that. Starts with e. Before simplify.
Expand.
Yeah, you had to expand. Before you could simplify. So what in the numerator, what exactly we have to expand?
The x plus h
Yeah,
squared.
and I expand that. Right. Could you tell me what x plus h squared is off the top of your head? You know how to say yeah, but can you?
You can repeat what I say break up just now.
Oh, can you tell me what x plus h squared is off the top of your head? Like just one time.
Um, as a like expanded version,
Yeah,
or
like
just like
yeah. Could you expand that in your head, like mentally?
um, it'll be x squared. I don't think I can. I don't think I. It's not, I don't think I can do it in my head. I think I had to write it out.
All right, well, let me write it down. Right. Expand it out from there.
So it'll be x squared and then add x h
We will say 8x.
hx. Okay.
Then
Then it'll be add hx again, and then it will be h squared.
Right, what next?
You put back the minus 3,
Right?
then you put back the minus x squared minus 3.
Okay. But we
Oh, yeah,
see, yeah, so we had to expand that too.
okay. It will be minus x minus x minus 3. I don't know if I
So now again?
minus x, then minus x again.
No. Watch. The negative sign on the outside means you're going to multiply everything by negative. So negative by x squared is negative. No overthinking. Negative by x squared is negative
Negative x
x
squared
squared. And then negative by negative 3 is,
plus 3.
yeah. And in the bottom now, you can see anything that you can simplify. We have x plus h minus x.
Um, yeah, the two x's,
X is good what?
they combined to be like um h minus x squared.
What? Wait a minute.
No,
You're right, can't I worry, man. Little bit. Check it out. 5 minus 5. Would that be 5 squared? If I have
no,
5 minus 5. What would 5 minus 5 be?
0.
Right. So what would x minus x be?
It just be h on the bottom.
Yes.
Okay.
Right? Just be h. Right? And Kira, you wasn't there for the last class, so I want you to help me with this question. So it's help me with this question. Right? So Kira, what we're gonna do next line then? We already expand. What are we gonna do?
Simplify.
Right. You see any like terms on top?
The 2x squared, the 2hx.
Right? So we have x squared and we have minus x squared. What happened there?
That'll be 0.
That'll be 0, so we can cancel all that.
And then hx add hx is hx squared.
I noticed you doing that. When we add, you don't get squared. What does squared means?
2hx.
2hx. It'll be 2hx. Let me ask you a question. What does squared means? Is it addition, subtraction,
Multiply or
multiplication?
multiply.
Right, not addition. This is 2hx. Right? You see any other like terms?
The minus 3 and the positive 3.
Without canceling.
So it will just be 2hx plus h squared over
That's
8.
correct. That's correct. Okay. And what is the next step?
The h could probably cancel off with 1 and the h from the h squared. So you
No,
just
can't do that.
no,
You can't do this. You can only
no,
cancel off
none
terms
of that. It'll be from the h squared.
like that.
Yeah, so it'll
You
just be
can't do that,
2h.
Can't do that. Aliyah, tell Kira why she can't just cancel off like that. If you know.
Razor and no.
Yeah.
Because wait, would she want to cancel off the h squared and the h?
She wanna do that.
Oh, no, you can't do that. And just because you have an operation
Yeah, yeah.
and it has
You
no
have a
bracket.
you have a sum. You have a sum there.
Yeah.
So yeah, Kiara, you need to what? Let me look at the steps. Expand, simplify, then.
Factor.
Yes. So you could only cancel off when it's a product and a divisor. You'll see what I mean. You'll see what I mean just now. On top, are there any things you could factor out? Are there any things you could factor out?
No.
So you don't have anything in common with this and this. Take a close look. Is there anything in common with this term and this term?
The H's.
The H is. So we're gonna factor out the H. If I pull out the H, you see, notice something. Now the H on the outside, and we have brackets. That means multiply. So now we have multiplication, right? So if we pull out the H from this, what would I write? If I pull out the H from 2hx, what would I write?
H by H.
Hmm. If I pull out the H from 2hx,
Also you put 2 in the bracket.
what next? So I pull out the
Add
H from the
X.
2hx.
So the H 2 R X.
No, it will be 2x.
Oh,
Because here, we pull out the H from this. So if you pull out the H, then it's 2x. Because we want to get back 2hx. If I pull out the H, then there's only 2x there. And Kira, what is H by 2x? What is H by 2x?
2 H X.
Correct. Nice. If what let me ask that question first. What is H squared? What is H squared?
H by H.
So if I pull out a H from that, what that will be?
Just H.
Correct. Max, that question on top. You have H being added, multiply, divide. What going on? H being
Multiply.
multiplied by this. So now we could actually cancel it off if you wanted. Right? So we're gonna cancel off the H and the H. So what do we have now?
Just 2x plus H.
Yep. Awesome. And Kira, is there any X terms in the 2x? I mean, what I'm saying, are there any H? You seen any H there? You seen any H in the 2x?
No.
So do we really care what happens to H here? Would that affect the 2x?
No.
No, because the 2x don't have any H in it, right? So we both could agree 9 what happens to the 2x. Could we agree on that? Nothing would happen to the 2x.
Yeah, nothing would happen.
How about the H though? What we saying?
The H will eventually
It will eventually become
0.
right. So what's the only thing we'll be left with?
2x.
That's the answer? Yeah. So these are the steps, right? You all can copy this down. This is an example. And after this, after you all copy this down, we're gonna do an actual question. All right, guys, you all have this copied down.
Yeah.
Okay.
Yeah, I finished.
Nice. Let me look at the actual question now. So this question here was actually from 2024. Yeah, this is how the question actually looked like. So, Aliyah, why to give that question a read?
Use the definition of the derivative as a limit to find f prime of x for the function f of x is equal to x squared minus 3.
Now we know how to differentiate that normally, right? That'll just be 2x. Simple. And we know how to do that?
Yeah,
Yeah, but they don't want that. They want we to use limits something. So entering the formula for limits, if we're gonna use limits, what's the formula for that? A limit is tell me.
it'll be each to approaches 0.
Mm-hmm.
F of that'll be x plus h.
Right?
Um,
So remember it's y2 minus y1. So f of x plus h will be y2. What y1 will that be?
f of x.
Correct. And then it would be x2, which would be x plus h minus h. And what we say that was?
H.
That's it.
Yeah.
Right. So that's the formula I had to use. But once I let you get familiar with how they ask in the question, because they wouldn't just say use limits to find it, they would say they'll say all of this drama. They will say use the definition of the derivative as a limit to find all that. And we need to get in the habit of seeing how they will bring it. Um, so I'm gonna give you all a similar question to this. Similar question to it. Use okay, so Kira, from basic differentiation, how would we differentiate this? So what would f prime x be? The first derivative of that. Like, forget about limits, I think. I'm talking like basic, like normal differentiation, like, how would we, if we differentiate this, what would we get? Kira?
Hi.
Yeah.
Um, uh, What's the question you asked? Repeat it.
Okay. I want to say something, yeah? Pay attention, please.
Okay.
Were you paying attention or were you
Yes, I was.
Oh, I know the Wi-Fi giving some trouble, but yeah. So I was asking you how would we differentiate that, like normally? Like if we differentiate that. Forget about limits and thing. Like if we just differentiate it. Remember how to differentiate?
Yeah.
No?
Yeah.
Okay. When we differentiate it, normally we take in the power, multiplying everything by it, and then minusing one from the power. So if I had x squared, that is 2x to the power 1. Here's another example. If we had, let me just say we had 2x cubed. That would be 6. I take the 3, multiply by the 2, 6, take away 1 from the power, squared, 6x squared. If I differentiate 9x squared, what are we equal to? See if you can figure out that. If I differentiate 9x squared, what that will be?
18x.
Yeah, 18x. And if I differentiate, anytime you differentiate something in the form ax, your answer is just x. Oh, no, sorry, not x, it's just a. So if I differentiate 3x, that's equal to 3. If I differentiate 9x, what would 9x be equal to?
9.
9. And lastly, if you differentiate a number, it's just 0. So if you differentiate 2, that's just 0. Right? So that's the basic concept there. So from normal not integration, from normal differentiation, if I differentiate this, well, what should it be equal to, Kiara? What should it be equal to? If I differentiate x squared, what that is? So you're taking the power, you're putting it in front, you're multiplying, and then you're minusing 1 from the power,
2x.
right? And if I differentiate 3x,
Um, 3. I 3.
3, and if I differentiate 2, that'll just be 0. That's
Yeah.
it. So when you solve this question, you're supposed to get 2x plus 3. Right, so I want you to try this question here using limits. Right. Amy, how this question looking?
Okay. Okay. Yeah.
At least it's not cubic. If you know, you know.
Yeah.
Yeah. Aliyah, you getting through for this one?
I trying something.
I feel like what might give all this some trouble is finding f of x plus h and thing. That is from maths. Um, just give a little refresher, right?
Mm-hmm.
So remember, what's the formula again to find gradient? Is the limit as h approaches zero.
F in f of x plus h minus f of x over h.
All right. So we need to find f of x plus h. Do you know what that means? F of x plus h. Tell
Um,
Malia. If I tell you to find f of 5, how you find f of 5?
f of 5, you're replacing the x with 5.
Cool. So if I have f of x plus h, it's the same thing. Anyway, you see x, you're gonna write x plus h.
Okay.
So I want you to tell me, what should f of x plus h look like? That should be equal to.
F of 2x plus h.
Oh, wait, this over here, this is not f of x. This is the answer you're supposed to get. You're supposed to get 2x plus 3 when you work it out. This is the
When you
function.
differentiate, yeah.
So when you find limits and everything, remember, Ali, I remember this over here this is the same thing as the first derivative. Eh? This formula
Uh-huh.
here is another way to differentiate.
Okay.
But the normal way to differentiate, you get 2x plus 3 and you're supposed to get that over here.
Yeah,
This,
that's what I get.
this is the function here.
Mm-hmm.
So we need to find f of x plus h. How are we going to find f of x plus h? Anyway you see x, you're going to replace it for x plus h.
Oh, so it could be x plus h squared.
What, in brackets or not in brackets?
Yeah, in brackets. Plus 3 into x plus h plus 2
Right.
over, no.
No, that's just f of x plus h. You still had
Yeah.
just
Yes.
f of x something. So yeah,
Mm-hmm.
you gotta expand that and simplify it. All that drama. Okay, Alia, come up with,
Um, I just have to factorize now.
all right.
I can send you what I have so far to make sure I'm going good.
Yeah. Um, Amy, how about you? How are things going?
I wanna send you my answer now.
All right. And Kira, how about you? What going on?
I think that's okay.
So Alia, you went ahead and find f of x plus h. Oh, by the way, Amalia, you see we have f prime x is equal to 2x plus 3. Just put in brackets or somewhere that is the answer. Just put that as the answer.
Okay.
So you have x squared plus 2hx plus h squared plus 3x plus 3h plus 2. Yeah, you're going good so far. Yeah, you're going good. See, now you need to put it into the formula.
The formula.
Yeah,
Oh, okay.
because watch, you find f of x plus h, but you find it one side. So now you need to put it back in.
I don't understand.
Okay, so um, did you okay, let me show you our difference, right? Let me just say you do it in the question itself. So let me just say you plug it in into the formula one time. It would have looked something like x plus h squared plus 3, x plus h plus 2. Then you put in the part with the minus f of x. So you say minus x squared plus 3x plus 2 all over h.
Oh,
In.
okay.
But
So now,
you did f of x plus h separately.
you're just putting in the last line into the formula.
Yeah, so whatever you just now found, you're gonna put that in for f of x plus h, and you're gonna put the minus f of x all over h.
Okay.
Amy, things looking good, right? Yeah, things looking good there. Amy. Nice job. All right, so Aliyah, getting through?
I think so.
Okay.
I could find for f of x first.
Yeah, well, I mean, f of x is already there.
Oh, yeah, yeah, yeah. So just plug everything in.
Yeah, but you gotta be careful because it's minus f of x. It's not f of x. So what that means is that is minus
The
multiplied by
square.
just the x squared or
The whole thing?
yeah, the whole thing because it's minus f of
F
x.
of x.
F of x
So
is
it'll be minus x squared minus 3x minus 2.
yeah,
Okay.
that's what we're talking about. Yeah, so Aliyah, things are good.
I sent you a picture. I had a factorize now. Like simplify, but like
Okay.
I send the picture.
Let me check it out. You going good? Yeah, Aliyah, you going real good? Continue. You'll get your answer. Okay,
I'm
that
not sure if it's not correct.
let me ask you a question. Why would he do that? Why just not pull
I
out
don't know.
everything?
The H because I don't know because it
And all the terms you have there have H in it.
yeah.
Then you could pull out H from all at one time.
So it could just be 2x plus H plus 3, sorry.
Wait, here what? I want to erase
That
that
what you mean?
I have. Let me show you what I mean. If you have H
Mm.
squared plus 2hx plus 3h, don't all the terms have something in common?
Yeah.
So we could pull out H from everything. So you pull out H. Um, so I'm pulling out H, right? If I pull out
Oh, okay.
H squared.
Yeah.
Yeah, so proceed. Because
So
how you have that there, we can't cancel off anything because there's an operation being added. Two terms
wait,
being
so
added.
it could be H and the 2x
Wait, sir?
and the 3 in brackets.
Wait, tell me.
2x.
No, it will
It
be
will be H
H.
plus 2x plus 3.
Yeah,
Okay.
that's it. And you see how we have h being multiplied by this whole thing?
Yeah.
Now you could cancel off because h is a product. Is a product there on top.
So the h on the bottom will cancel off with the h outside.
Yes. All right, Kira. Wait, Aliyah, so that's what you have there. All right. So Aliyah, now you need to take the limit of that. Now you need to take the limit for that. So you're going to put on a line. So Aliyah, you see how you do the working is correct, if you want, this is what you could do, right? So like you could do what you did. You could work this portion by itself, and then the last line, when it's simplified as much as possible, then you could apply limits. That's fine. So
Okay.
what you have right now, you're just gonna say the limit as h approaches 0 for h plus 2x plus 3, that'll be equal to,
Oh, okay. So it would just be 2x plus 3.
and we know that that is actually in fact the answer.
Yeah.
Because when you differentiate it normal way, you get that.
You get, yeah.
Awesome. Nice, man. Let's go. Let's go. Say good.
Yeah.
Nice. Kiara, let me run through what you do, and I'll wait for class today. So, Kiara, tell me, how did you, I see in your answer you have plus 3 minus x squared. Where you get plus 3 from?
When I was this thing expanding, well,
Wait. And I see that I see you have,
unless I do it wrong, I probably make a mistake somewhere.
I see you have an arrow by the 2 multiplying by the x squared. But then you expand it correctly. Let me run through the question because you, you're working on looking that wrong. It's just something looking a bit weird. So I want to explain what you do. So let me run through the question together,
Okay.
right? And let me see what happens. So if you all want, or you could do it like Aliyah. How Aliyah did it, she did it in parts. So not to us so as to not confuse herself, right? So Kiara, this is how Aliyah do it. She said f of x plus h, and she put her aside and she find for that. So she decided to work that separately. So Kiara, I believe you do that part correct. You get x squared. Tell me what you get, Kiara. You get x squared.
X squared plus 2xh plus h squared plus 3x plus 3h plus 3.
Wait. That's supposed to be 2.
2. I'll probably make a mistake.
Yeah, look at the question. Look at the question. What was f of x? F of x is equal to x squared.
Yeah, I make a mistake. Oh my god.
And another thing, right? Actually, no, you're good. You're good.
Okay.
Yeah, you're fine. But just
Okay.
okay. Well, that's probably why you get the correct answer. And That's why I get confused. You just probably write a 3 instead.
Yeah.
Okay. I don't know how you will see that 3, but
I don't know.
well, understand what one. You, you was probably looking at this,
Yeah.
and it was like, huh, let me just make this a 3 real quick. No, this is the answer. This is where you're working towards. You'll get this answer. But you can't just change that 2 to a 3. They can't do that. Just change that 2 to a 3, right?
Okay.
You that's crazy.
To
I
be honest, I probably, when I was writing it, I probably meant to write two and I write three instead.
no, but like I see like you're right too, and then you just in pencil you make it look like a tree. I don't know. And looking like that in the picture.
I don't know what, it was my mistake. I was probably writing too fast.
Right. So let me move along with the question. So we know what f of x plus h is. F of x plus h, that is x squared plus 2xh plus h squared plus 3x plus 3h plus 2. Now we need to work the other part, right? So minus f of x. Minus f of x, that means we're going to minus all the terms here. So all the terms in f of x, a minus sign is going to be applied to. So Kira, let me look at something. Let me look at something and then it might make you do the wrong thing in the exam. I see you put the arrow starting from 2. Kira, is 2 in front of the
It was supposed to be from the minus sign.
right? Minus sign is supposed to be from. Right? And this whole thing over h. This whole thing was over h. Right? So let's proceed. X squared plus 2xh plus h squared plus 3x plus 3h. Yeah, and let's expand now. If you expand now, we'll get. Yeah, if you expand that, some of us. I think you expanded it correctly. Yeah.
Okay. Alright, so is the x.
You expanded this.
Yes, no. I think yours is different from what I do. I expand that and
Let me look in the front. I didn't expand this yet, so no, waiting for you to tell me how to expand this.
oh, right. So after that, I put minus x squared
Right?
minus 3x minus 2
Minus 2 or plus 3. I mean minus 2 or minus 3.
minus 2.
Okay. Right, and then we have over h. And now let me look to simplify. You seen any other x squared terms?
Yeah, so both of the x squared was cancelled off, and then I cancelled off the plus 3x and the minus 3x, and then the yeah, I think I meant it was all two because I did cancel off the twos.
Yeah, because that's why I know I seen the correct answer. It's just I don't know where you get 3 from. That kind of confusing now.
I think I meant that two. I meant that two in my mind. My mind was good. Okay.
Okay. So you end up with 2xh plus h squared plus 3h all over it. Now, what's the next step? What we need to do now?
Um, put like H in front,
So
like
where's the
multiply everything by H.
so let's have a word for it. That's what F.
Factorize.
We're gonna factor out the H2. Yeah, we're gonna factorize by factoring out the H2. So if I pull out H from 2xh, all right, on the inside.
2x.
If I pull out H from H squared, what I left with?
H, so plus H.
And if I pull out H from 3h,
3.
could I do this?
No. I mean, you could do it with the one on the outside, and
Right, because the one on the outside is a multiple. It's being multiplied by something. So we end up with,
2x plus H plus 3.
right, now we need to take the limits of that, right? So look at what I did, right? Look at what I did. The formula says if you want to find the, oh guys, I wanted to add this, this is the formula you use to find the first derivative. So just include that f prime x is equal to limit as h approaches 0, right? Because this formula is the first derivative. So I'll just put that in. This formula is another way to find the first derivative. And so just include that f prime x is equal to that. So if I want to find the first derivative, which is f prime x, I need to take the limit. This would be equal to the limit as h approaches 0. And Kira, and we already find this, we already simplified.
Yeah.
What else?
2x plus 3.
Plus h plus 3. We didn't find the limit of it as yet. We're gonna do that now. So anyway, you see in h that should go into 0. So where's your final answer?
2x plus 3.
Yeah. So I would say that this is an easy topic. It's just kind of long, but I feel like it's easy. Easy. Right? I didn't get to do quotient, product, and thing today. I guess I gotta do that next class. Before we go, I'm just gonna show you what we had to do again. You would have to learn the first derivative of trig function. So like if you differentiate sine, you get cos. If you differentiate cos, you get minus sine, those kind of things. You need to differentiate ln x as 1 over x. You need to be able to differentiate e to the x, which is just e to the x. You need to know the product rule, quotient rule, and chain rule. I don't have it included here, but you still need to know it. Aliyah, you ever did this? Like ln x and e to the x? That's additional stuff. I just showed on it, but
No,
Aliyah, ever do that in school?
no.
Okay. All right. Well, yeah, that's it for class today. Next session is trigs, product, quotient, and chain. Right? So I'll see you all next Saturday. Kira, thanks for coming to class today, even though you come late. Just talk to your friend Nicholas if he's still asleep.
I tried calling him when I wake up and I realized I was late. I tried calling him and he wasn't answering.
Because I messaged his mom, and his mom told me that he's sleeping.
Okay, I will talk to him.
I'm going to talk to him, give him a slap.
Okay, no problem.
Yeah, tell him, hey. But then again, he is normally come to class, so I can give him a little blind, you know.
Yeah, I guess. I really got him soon.
What? Anyways, I hope all you enjoy your day. Amy, I'll see you just now. More or less. I'll see you just now, Amy.
Yeah.
Oh, I'm for you. Later, everybody.
Bye.